I don't have any. Yeah, we're just going to let it right there. All right, so we saw some co-function identities. And today we're going to get three more flavors, just kidding. Co-functions, they exist, they're fine and dandy. We have that one. We're going to look at some other ones much quicker. We get what are called the reciprocal identities as well, which, hook it up real quick. What's a reciprocal? So one is an example of a reciprocal in itself, but like, is there like a hand gesture that you think of when you see reciprocal? So you can do this, and you can get metal with it if you want to, or yeah, right? Okay. What is it?
Say it.
Do it. No.
He won't say it.
What? Say it.
Oh,
I can't do it anymore.
Because you can do this to your class and think it's funny. You can say hello, right? Okay. Well, you just said it.
I said.
Well, I mean, as a teacher.
I don't care. Yeah.
Okay. Because.
So do it. Just do it. Everyone did it.
I'm not gonna do it. Now do magic photos of
Hey, show me something that has a woe and hella in it.
What is it?
Okay, just because the comment came up with, can you say that, the other day, so I often say stuff that I go home and I think about, and I just lives in my head for like days on end because I'm always worried about it. The other day I was trying to explain pretentious to all the freshmen, and they didn't quite get what I was saying, so I just said, no, it's going to make you sound like a douche. And they looked at me like I just said the worst possible thing. Do people still talk like that?
douche?
Yeah, like if somebody's being a jerk but not a mean, they're just being like pretentious. Is douchey a word that still people use or not really?
Yeah.
Not super. So it depends. Okay. Anyway, reciprocals. Check it out. We're only going to write a couple of these. If you took sine, how did we define sine the other day? Y over, not x. Y over 1 is what we did when it was on the unit circle, or y over r is the other way that we did it. And I'm not even sure if we saw that one yet or not, to be honest. But what we do have is the following. I'm only going to do 3 of these, but let's take a look. Sine of theta. And what we're going to get within here, and it's weird, is we're going to get a bunch of different ways to define the same functions. So sine, we started with its y. And then we jumped to its y over r. Now we're going to see another way to do it. Sine of theta can be written as a reciprocal. And what I mean by that, and let's think about this, if y over r was sine, if we did it as r over y, what did it become? Sine, and you might have to look back at how we defined them. Sine is opposite over hypotenuse. What's hypotenuse over opposite? If we flip it, we do the reciprocal. It's not quite secant. They don't match as nicely as we want them to.
Cosecant?
Cosecant. So check it out. Sine, because I know that we just take it, we flip it, we could instead write it as 1 over the cosecant of theta. It's just the reciprocal of cosecant. And this is just another way of writing it. Instead of switching it as being y over r changes to y or r over y, we're just doing it to begin with. Sine is the same as 1 over sine, and we're just doing the reciprocal there. What do you think we can say is true of the cosine as a reciprocal identity? 1 over secant. Because secant and cosine are reciprocals of one another. Now there's one more that I'm going to write here with the understanding that there's 3 that we're not writing, and we'll at least talk about one. What about tangent? 1 over cotangent. Now, the reasoning behind these, and it's going to be less clear on this side, is right now, if I said what's the easiest to think about, sines, cosines, tangents, secants, cosecants, cosecants, which ones are the easiest for you to think of in your head? Sines and cosines, in my mind, even with all the practice, they're way up here. Like, I can think about them pretty easily. Tangents is a little ways behind. But then when I get to the other ones, I just have to do the extra work because I don't have them just locked in my brain yet. And I probably never will at this point. But can we all agree that sines and cosines are probably nicer than some of their counterparts? Yeah. So the reason that we would ever do these, and I want you to finish these on your own. We're not going to do them all right now. But what do you think I could do if I did the same thing with cosecant? if I get something that has a cosecant in it and it looks awful to deal with, maybe, just maybe, it would be worth it to, instead of writing cosecant, to simply write it as 1 over sine, so that we can now think with sines and cosines instead. It is so much nicer to change these. Which one would I write here? Dang it. What's secant? We're just going to commit to it. We're already here. 1 over cosine. And I would do this if I wanted to think in terms of cosines instead of secants. There's one more, Addison. What is it? And cotangent, we can think of as being adjacent over opposite is one way to do it. We can think of it as x over y, or we can think about it as 1 over tangent. Okay, we're not going to say a whole lot about these right now. We are going to use the heck out of these, for sure, I guarantee it. Okay, the last one. There's actually 2 more, and I keep getting excited. Okay, I'm just trying to see how your notes look. Do you guys always have a whole lot of empty space on the right side of your notes?
No.
Okay, so just keep working downward?
Yeah.
Okay. So we get the reciprocals. We got the cofunctions. We get the quotients. And these are just identities. Again, these are just ways that we can rewrite, and we won't get to see for like why we would necessarily want them now, but I assure you everything that we're going to write here, we will not write something here that's not super valuable to us. I assure you. Okay. What's tangent defined as? And there's several answers. Excuse me. Y over x. And what's y typically? And x is typically, so check it out. We have 2 quotients. The tangent of theta for any theta is y over x, if we want, or we can simply say it's the sine of theta over the cosine of theta. Now, there's all sorts of wonky things that we could do to rewrite these, and eventually we will just do a little bit of practice with it. But sine over cosine, there's one more quotient identity that we get. If tangent is sine over cosine, do a hella something and get what? Cotangent. How would you define cotangent? So think about what happens. Tangent is y over x. Good. Say it again. Cosine over sine. Cosine theta over the sine of theta. All right. Should we see if Krina knows today's word or not? I think that's the game that it naturally became the other day, because just so you know, this comes from a place of envy. I was so impressed that you knew this word. I don't think you'll know today's. I don't think you will. And there's actually 3 today, but I'm only going to give us a couple of them.
You should guess definition after he says the words. Compare if you're right.
Okay, the first of these. Just a reminder, what's a conflagration? A big fire that spreads. Conflagration. I don't know we're going to pause it here. Rankling aside, we get some new ones. Okay, there's one more, and I'm confidently going to say this is the most important, and then realistically, like 5-10 minutes, we'll do a problem with this. The last identity. There's 3 of them, but I only care about one of them, and we'll see why. The last identity that we get are what we call our Pythagorean identities. Now, you guys already know the Pythagorean theorem. Pythagorean identities. Now, we're going to draw this picture for this one, and it's the only one for today that we need the picture for, but we're going to make sense of it. When you see Pythagorean, what does it make you think of? What shape? Triangles. But we're right triangles even, love it. But we're talking about unit circle and trig. So I'm going to draw just quadrant 1 of our unit circle, and I would encourage you to do the same. And if it's quadrant 1, I'm going to put a point right here and a point up here. How far does the unit circle go? Like, what's this ordered pair? 1, 0. And then up here is 0, 1. Speaking of Basil, I have your unit circle quiz because you weren't here when I handed it back the other day. Okay, so I'm going to sketch this, and you will not have to draw it again to do this, and we're just going to say that's a nice circle. Okay, red said right triangles. Do right triangles show up on my unit circle? Yeah. Oh, everywhere. Everywhere, everywhere, everywhere. Now, I'm just going to pick an arbitrary one. and I don't know where it is. It looks like it's between 45 and 60 maybe. Here's a right triangle. And we're just going to make sense of this. And I'll let everybody catch up. It blows my mind that you saw the word. I'm so proud that you saw that and that you knew what it meant. That's awesome. And then other random thought just gets in my head. The other day we were doing the card things. So, Wisha, you and I will forever share the uncomfortable memory where I kicked the ball right at your face. I'm never going to forget it. But the other day I actually got a new one from somebody because I was doing these cards and we're just like tossing them out to say, hey, just do something. And I was just sitting here tossing them. And I'm pretty sure it was Delilah sitting there. I was going to toss it. I just tossed it and smashed her right in the face with a card from like close range like that. But, so that's new. Just thought I'd share. All right. If we were going to do X and Y and R, because Pythagorean theorem can be written ABC or XYR, this would be the what? So you're correct, but let me, out of the three choices, X or Y or R. Sean. Yeah, absolutely.
Oh, okay.
So X, yeah, I think so. What about this one?
Oh, Y.
And this one here? R. Now, we're going to not think in X's and Y's and R's, which is fine and dandy, but I do want to use this idea. The Pythagorean theorem, and you can write it if you want to here, do you agree that instead of a squared plus b squared is c squared, it's probably just going to be x squared plus y squared equals r squared? Like, that's the same Pythagorean theorem that we've seen, the letters, if this isn't natural, though. But I want your help. Let's pick out this point better. This point up here, we could write as x comma y, unless we're feeling super tricky about it. Instead of x, we know it's what? Which trig function gives me the x value? So let me,
Cosine.
it's cosine. Cosine comma sine is how our points all look, right? X comma y. Do you guys agree that instead of x comma y, we could just say this is cosine of theta for some theta, and I'll even draw the theta in down here, and that the y value here is just the sine of that same theta? It is super important, Matilda, nice job answering that, but I've got a lot of blank faces when I asked about it. I need, like, yes or no, this makes sense or it doesn't from you guys. If we look back, and we have to go a couple days, look to the first time we wrote cosine, it's probably 4.1. Tell me how we define cosine. And I bet it's glad you did this. Oh, it's x, right? And then if we went a day further, all that we changed it to was, we had it x, and that was it. And then we could write it like this, which is just the opposite over, right, Jason, over the radius. Can we all agree that cosine we wrote when we started, cosine is x? And sine is y. On your unit circle underneath, we wrote the order of pair cosine comma sine. We're going to use it. Now, the reason that I'm stressing this so much is, could we write our Pythagorean theorem instead of a distance of x? What do we just say was the same as x? So check this out. We get some ugly notation here. I don't want you to write it the way I do the first time, okay? I'm going to write it in purple. Don't write this one. But what we see is if we just try to apply this to the Pythagorean theorem, instead of x, we could write the cosine, don't write this yet, of theta squared, plus, instead of y, what could we write? Sine of theta squared. And that would equal what on my unit circle? So careful. What is the radius r? And I like that thought. I can see why that would be the, like, in your head. But on the unit circle, it's 1. It'd be this, right? Okay. You will never see it written this way. Here's what's weird about these. When we write the cofunctions or trig functions squared, our notation changes a little bit. And the way that it's going to write, and this is where I would jump back in. There's 3 flavors of this Pythagorean identity, but the first one's the only one that I really truly care about. Instead of cosine of theta, that whole thing squared, we typically write this cosine squared theta. Super duper important to Addison. I think you're zoning out a little bit, and I get it. This and this mean the same thing. If you were to just write this, you are not giving me the right value, because this, the implication is that that's what's happening. The cos squared theta. Either one of these, you'll never see people write it like that. Like, that's a weird way to do it other than to make sense of it. This is how it is actually written. Sorry. Okay. Plus, how should I write this one? Sine squared theta equals what? 1. Check it out. This is always true. For any angle theta, if you do sine squared plus cos squared, what does it always equal to? Every single time. Now, you guys are going to help me. I'm going to help you, rather, with one. We're going to get one more Pythagorean identity out of this. And then you guys are going to get one on your own also. Now, I don't care which one we go through, but these are 3 flavors of the same idea. I'm going to be honest. This is the only one that I remember off the top of my head. The other 2 we get for free, but we're going to see how do we get them. If I wanted instead, and I'm not doing these in a particular order, just so you're aware, could I divide both sides by something to get rid of this cosine squared? If I wanted to make a cosine squared fall out, could I divide everything by cos squared? Okay, so I'm going to do some scratch work off on the side. I don't know if you want the scratch work in your actual stuff, if you just want it off to the side like I'm doing. But if we start here, if I divided everything by cosine squared, I'm allowed to do that, right? So that would happen here. It would be plus sine squared theta over cosine squared theta. Is that true if I say this equals 1 over cosine squared theta? All I've done is both sides just got divided by cosine squared. And I've elected this completely randomly, sort of random, I guess. I just want to see, can I make this look different? And that's all that we're looking right now. I could have elected to divide both sides by what instead? I could have divided by sine squared as the other obvious choice. But let's just see what happens with this. And there's no real more scratch work. I don't remember these ones. I only remember this one. What's cosine squared over cosine squared? 1, right? Anything over itself is 1. Plus, what's sine squared over cos squared? Tangent squared, because it's sine over cosine, and they're both squared. So sine squared over, it's tangent squared. So what we just worked out is another version of the same identity. I get 1 plus tangent squared is exactly equal to, what does this right side turn into? 1 over cosine is defined as secant, so 1 over cosine squared is secant squared theta. We get another way to write it. And the whole reason, we're going to see this in the coming sections, but if I have a 1 written somewhere and I have a bunch of other trick stuff and I need to simplify it, all of a sudden we can replace a 1 with this. And now we have a way into the problem. Or we can replace a 1 and we can rearrange these. There's one more that I want you to get for me. I'm going to do this one in this indigo color. I want you to get me the third identity. We did one where we didn't divide by anything. I did one with you where we divided by cos squared. What are you going to divide by? Sine squared. If you don't need scratch work, I'm cool with it. I'm okay if you don't use scratch work, if you can just think it out. But if you need a little scratch work, I'm also cool with it. Okay, it can be either. Instead, I'm just dividing everything by sine squared. What's cosine over sine? So now we get cos squared over sine squared is cotangent squared theta. Plus, what's this sine squared when I divide it by sine squared? 1. And what's 1 over sine squared? Cosecant squared. And look at that. I only remember this one ever. Like, once we start rolling and doing a bunch of problems, I'll probably use green and blue a little bit. But I only ever remember red. Always. Okay. We're going to do one problem together, and then I want to see if that's enough. If we have to do another one, we will. But I want to try one problem together using these identities. We get some more coming later, but I think we get to learn how to graph stuff first, which I'm very excited about, because you guys love graphing, right?
Not this.
You will. You will. It's so easy. It is so easy. Real quickly, what is the domain of sine and cosine? All reals. The range,
1, -1.
I would always go the other direction, but I agree with you. From -1 to 1. All right. Last thing that we're going to do as a class, and I thought this was going to go much faster, but we have one example. I want us to find, for the following, sine and tangent of theta, find sine theta and tangent theta without calculators. All right, love it. And let's do it. So on our first one, let's see here. I want to simplify that down. Sweet. We're going to go ahead and just do one problem here. I'm going to call it A just in case we need a B anyway. But using these identities, and I'm not being any more specific than that, we're going to say let theta be less than 90 degrees, which simply means it's a what sort of angle? Acute. So we have an angle theta less than 90 degrees such that I'm about to give you the sine, but I better give you something else. The cosine of theta equals 24/25. Boom. I want the sine and the tangent. Now, I want to do this without using calculator stuff. So let's see if we can't work this through. Right now, I know sine, right? Now, could we use Pythagorean theorem and build the triangle and try to do sine of theta and cosine theta that way? Is there anybody who hears me say that and might agree, but you don't really know what I just said? So, the way that we're not going to do it, and what's weird about this is there's so many options when we're doing trig. I'm just trying to make sure we can see them. The way that you guys did these on your homework, if you did it, is we would sketch an angle, and don't draw in red right now, and we'd say here was theta, and then sine is opposite over hypotenuse, right? So the opposite from this would be 24, and the hypotenuse would have been 25, and we could work out this, and then we could just plug them in, right? That's one way to do this problem, and it is completely valid, and it works really nicely because I gave you the fraction. On my sheet, instead of 24/25, I have 0.96. And if I presented it like that, you'd probably be a lot less willing to draw this triangle, which that's reasonable. You should be less willing to draw the triangle in that situation. Even though they're the same, it just looks more intimidating. But here's what I think we can do. If I don't want to use that triangle, and I only want to use these identities, if I have a cosine, do any of these functions say if I have a cosine, I can solve it for sine somewhere? Now, maybe this one, if I had a secant, but I don't have it, so that's a bummer. This one, if I had the tangent, it might be useful to us, but I don't have the tangent, right? I only have the cosine. Does this have a cosine in it? And the only thing that I wouldn't know if I plugged that in for cosine would just be sine squared, right? Let's use this identity. Without ever actually drawing our triangle, we can use this Pythagorean identity right off the bat to solve. And let's do that. I want to find the value of sine theta. Now, the Pythagorean identity just reads sine squared, and it's really hard for me. I will incorrectly, when I'm just thinking it, I'll just say sine squared instead of sine squared theta. It's going to happen, just so you know. What, no matter what, is sine squared plus cos squared always going to give me? 1. And which of these do I know right now? So I know cosine. So let's just plug in, right? Like, I know what it is. It's here. I'm going to underline it in orange, I guess. I'm going to underline that. We're going to plug it in. That means that I think reasonably true that sine squared theta plus, what's cosine? 24/25. And what's happening to that cosine? It's getting squared. If I were to do this calculation, what do they have to add up to? 1. Has to be. Now, as we go through this, I'm just going to try to clean it up just a little bit here. I'm trying to solve it for what? Sine first. And then once I get sine, I can get tangent. So if I want to isolate just the sine squared, it equals 1 minus, do we really want to distribute it out, or should we just write it as 24/25 and keep it squared? Okay. Now I'm going to switch just to green, 24/25 squared. Now, I'm only doing it this way so I don't have to touch my calculator first. Like, that's it. I don't know what 24 squared is off the top of my head. 625 is the other one, and we could probably work it out from there. If I want to solve for sine, what do I do? I'm going to square root it. So I'll take the square root of the left, and it just gives me sine theta. What's the square root of the right side of this? So let me rephrase. How do I start even writing it? So I'm being obnoxious and I interrupted you kind of on purpose, but it's a really bad habit of mine, so I'm sorry. Before I write the square root, what has to go there? When I introduce a square root into a problem. Plus or minus. Now we're going to talk about that here in a second. The square root of 1 minus 24 25ths squared. Now, I haven't touched the calculator at all yet. Couple things. Right off the bat, we're going to make a comment here, because if we don't address it now, it's just going to snowball out of control. Only one of these can be true, I think. If theta is less than 90 degrees, which quadrant are we working in?
1.
Has to be 1. In quadrant 1, is the sine value, the y, always going to be positive, negative, or can it be both? If quadrant 1, it's only positive, right? So we're just going to make a note here. Only positive because quadrant 1. Okay, I'm not even going to consider the negative anymore because I know we're in quadrant 1. So now that we're here, just a little bit of working here. I have no idea what this is, but I'm going to ask my calculator. 1 minus 24 25ths squared is 0.70784, but we're going to get it nicer than that. I'm going to frack it. It is going to give us, and we're going to leave the negative behind, but we're just going to jump back in. Are you guys okay if I'm just telling you what this number was? Good. Sine of theta is the square root of 49 6/25. And this one does simplify super nicely. What is the square root? 7/25. Now, without ever drawing a triangle or doing anything, we were just able to solve this. I legitimately don't know if I think this was easier or harder than doing it the other way. Comparable. But I do know that there will turn into situations where the other way sucks and this way winds up super nice. There's value in getting practice with it, regardless of the route that we wind up going through. If I now know the sine, what else was I asked to find? Tangent. So I want you guys, with what we have done so far, I want you to also give me the tangent. Just if you need it, I am going to pretend like we had to find it. I now know the sine of theta, and we knew the cosine of theta to begin with. There's a few different ways that we can get these out of here. Regardless of the route that you want, I want you to find for me tangent theta, and we'll meet back up here in like 30 seconds. How would you find tangent theta and do it? I guess is where I'm going to leave you. Red, I heard you say, and I'm going to just switch colors for each of my options here. The first way is that we can say tan theta, based on our quotient identities, is what over what? You could say it's sine over cosine. Okay, now I need to decide if we've done this. Anywhere have we written, I don't want to spoil it for you, but anywhere have we written something that looks like this. Cosine of theta is x over r. Have we ever talked about that? I think we did, where r was 1 on the unit circle initially, but I don't know if we've actually worked with it. Does that look familiar to us? Okay, if we've done that, check it out. We can think this way, which is sine, and we just found sine to be what? 7/25. And instead of writing divided by 24/25, what the hell happens? Yeah, that was a mistake, guys, just so you know. It's going to keep happening. 25 over 24? And I think we just found that the tangent was 7/24. Do you guys agree with that?
Yeah.
Now, there's another way that you could think about this. And we're going to get the same answer, and I'm apprehensive to show you guys like the logic to both of them. But if this idea that we just did is not comfortable for you, then this other one might be. What are you guys doing? Okay. Fair. All right. Beyond that, we also had a definition where we said that this cosine is x over r, and that this sine is y over r. Somewhere in our notes we have that. And then additionally, we said tangent, instead of thinking about it necessarily like this, somewhere we have written that it's y over x. If you don't want to have to use the quotient identity, we have another identity that we can get there with. What's the y value? According to this sign? 7, right? That's the y over the r is 25. What's the x value? According to this cosine? We get the exact same answer as before, just a slightly different logical path to get there. Okay, trig stuff, it just keeps going back and forth. The hardest part is deciding. Here's my honest advice to you. Just pick one, and if it doesn't go super smoothly, abandon it and try the other one. It takes practice to figure out which one's going to work the nicest, and the good news is I've got practice for you. So, for tonight, you are going to just add to your assignment, since we already did a bunch of it, and I want to double check to see if I had it over here.
So are we not allowed to skip any of them?
You can skip stuff, but I'm trusting your judgment with, like, I would try to do them a couple different ways. And remember, I don't know that I'll stay consistent with it. The skipping thing, it depends on how it goes. If the test winds up being absolutely awful, it's going to be out the window immediately. I trust you guys for now. Okay. 119, this is finish. 4.3, that took one extra day than I was expecting. That's okay. Trig identities is what we just did. And you guys are going to add. And let's see, I want you guys to add to the following. It's on page 287 still. 87. 41 through 51 odd. 55, 64, and 65. Cool. So, tomorrow, we checked up through 19 today, I believe. We're going to check all the rest of them. Sweet. You guys have like 7-ish minutes or so. You'll get a good start on it. I'll have you start now. We'll do some nice, chill something. I don't know. Cool. Have fun. Don't get too rankled.